Okay, we're going to do a third day today of writing exponential functions, and today's focus is only working on writing these exponential functions that deal with compound interest. All right, we can do simple interest using just a regular growth or decay model, but it takes a special formula to be able to do compound interest, and this is what the formula looks like. So things have changed a little bit. It's A equals P times the quantity of 1 plus R divided by N raised to the n times t power. Okay, this is it. We have to be able to work with this formula. Let's talk about what all of this means now. Number one, or the first thing, I guess, A represents your final amount. That's the total amount of money you have with interest included. P is your principal. Principal is the amount of money either invested or borrowed at the beginning. R is still the rate, and it's expressed as a decimal. N is the new thing, and it's the number of times the interest has been compounded. And I'll show you a list of possibilities in a second. T is still the time, which is the time that the money's been invested or borrowed. Okay, so there's all the parts that make up this formula. Let's talk about N real quick. So when you compound interest, you can do it a few different ways. One way is annually. Annually means you do it once a year. N would be one. And that's really basically simple interest. Okay, you could do it semi-annually, which would be twice a year, and that means our N would be 2. You could do it quarterly, which would be 4 times a year, where N would be 4. Monthly, 12 times a year, N is 12. And lastly, you could do it daily, which is you do it every day, 365 times during the year. Okay, so your N's are going to be one of these values today. Okay, you're going to divide R by one of these numbers. You're going to multiply one of these numbers by T to get your exponent. It's pretty straightforward once you get into it. All right, let's look at the first example here. Kareem's borrowed $8,000 at a rate of 15%, and it's going to be compounded quarterly. Assuming he makes no payments, how much will he owe after 3 years? Now, this is important. Do not round any intermediate computations and round your answers to the nearest cent, which is the hundredth. All right, what this means, intermediate computations, is don't do processes during the equation and round them. You want to do it once at the end. You want to do one calculation and round once at the end, and I'll show you how that works. So first of all, let's use our formula. This is a compound interest scenario, so we're going to use this formula. And let's find our parts. Okay, A, the total amount he owes, that's the question. Principal, he's gonna borrow $8,000. That's our P. Rate, 15% converted to a decimal, move it to the left, 0.15. N, the number of times it's compounded yearly is 4 because they're going to do it quarterly, 4 times a year. And then T is 3. So we got everything we need. Okay, take it right out of the equation. Now, let's plug all that in. So in place of P, I'm putting 8,000. In place of the R, I'm putting 0.15. N is 4, both here and up here. And T is 3. Now, all I'm going to do in my next step is multiply the 4 by 3. You don't want to do 0.15 divided by 4 and then put a rounded answer here. And we're going to get into numbers where you are going to get rounded answers. So let's just leave it like this. We need to learn to be able to do all these calculations at once in our calculator. So here's what we're going to do. If you just follow me with this, go 0.15 divided by 4, hit equals, and then add 1 to that. Now, you should just be able to raise it to the 12th power, and it'll say answer raised to the 12th power in your calculator. We're going to raise this answer to the 12th power, hit equals, and then multiply that by 8,000. And in one fell swoop, you're going to get the answer of $12,443.63. So if he borrows $8,000 at 15%, compounded the interest quarterly for 3 years, he's going to owe $12,443.63. So he's going to pay, what is that, $4,443.63 in interest over these 3 years. Interest, by the way, is money charged or earned for the use of money. Okay, so that's a pretty simple, straightforward application. Let's look at a different version here. Okay, a bank offers an investment account and they give you an annual interest rate of 1.27% compounded monthly. She's going to invest $4,200 in the account for 5 years. Same deal. Don't do intermediate computations. Round your answer to the nearest cent. Okay, so assuming that she doesn't take any money out, no withdrawals are made, how much does she have in her account after 5 years? Well, start with our formula. This is our compound interest formula. Okay. A, how much does she have total in her account? That's unknown. Principal, $4,200. Rate, 0.0127, right? Move the decimal two to the left. N, 12. The number of times it's compounded is monthly. There's 12 months in a year. They're going to do it 12 times. Your time period is 5 years. Okay, plug it all in. So in place of P, 4,200. In place of the R, 0.0127 divided by 12 to the 12 times 5 power. Okay, like I said, I'm just going to do 12 times 5 is 60. The rest of this is done in a calculator. 0.0127 divided by 12 equals plus 1 equals. Raise this answer to the 60th power. Hit equals. Multiply by 4,200, and there's your answer. $4,475.20 is how much she'll now have in this account. Okay. She'll have $4,475.20. How much interest did she earn? Well, take the amount she has total, subtract her initial investment of $4,200. She made $275.20 in interest. Okay. Pretty straightforward. One more example. Okay, she's decided to invest to help herself with her retirement savings. How much would she have to invest initially to have $132,700 after 17 years, assuming the interest rate is 3.49% and is compounded daily? Okay, so here's our formula. What do we know? Well, now we know what we want to end with. We want to end with $132,700. We want A to be that number. What we don't know is how much to invest to start with. We know the rate's going to be 0.0349%, I should say 0.0349, which is what 3.49% is when it's changed to a decimal. We know N is 365. We're going to do it 365 times every day. We're going to compound the interest, and we're going to do it for 17 years. Okay, so load it in. So now I want A to be 132,700. P is still the P. 1 plus 0.0349 over 365 raised to the 365 times 17 power. If I do 365 times 17, I get 6,205. Okay, now we want to solve for P. Okay, you got to understand that this 1 plus 0.0349 over 365 raised to the 6,205 power. That's a number. So what we can do to isolate P is divide itself by this number, divide each side. Okay, when I do that, these are going to cancel. This number divided by itself cancels out to become a 1. All right, so I got P remaining on this side. And what's going to happen is I'm going to do this calculation to get my solution. So in a calculator, depending upon how much you have in terms of ability with your calculator, you need to do 132,700 divided by this answer. Okay, there's several different ways you can do it, but you want to do it all at once. And if you do it all at once and do it correctly, you should get 73,319, which means if she initially invests $73,319, she leaves it in there for 17 years. It's compounded at 3.49% every day. She will have $132,700 left in 17 years, or remaining in the account after 17 years. Okay, so that's solving that process. Okay, you have a couple of those tonight. Set it up, show the work with that calculator so that you can do all those processes at once. Okay, that's really all we're going to work on today. Continuing to work on writing these equations, solving these equations, which are exponential style functions. All right, your homework's on Alex. I'll let you get to it.